Hello everyone. Today we are going to have a discussion on enrichment of uranium and downblending. So let's first talk about what is the present context of these words, of these terms. So present context. So these terms, they have been in the news in the context of US-Iran war. In US-Iran war. Actually Iran, okay, right now it possesses hundreds of kilograms of highly enriched uranium, which is in short we can call it as HEU. So Iran is in possession of hundreds of kilograms of highly enriched uranium, and this is a point of big concern for US and its allies. Okay, so they don't want Iran to possess that much of uranium, and they also have the capacity to produce more of it. They have the technical capacity for that. So what US wants through this war is that they want Iran to give away their highly enriched uranium, and they are pressurizing Iran to go for downblending of this enriched uranium. So let us now understand what do these terms mean. So we'll start from enrichment of uranium. Enrichment of uranium. So if we talk about natural uranium as a fuel, so natural uranium as a fuel is always found as a mix of these two isotopes, uranium-238 and uranium-235. So when we talk about natural uranium, uranium is which we extract from the land crust. So the uranium, naturally occurring uranium, is always found as a mix of these two isotopes, uranium-238 and uranium-235, in which the abundant isotope is this. This is the abundant isotope, and this is the scarce isotope in the natural uranium fuel. Okay, so around 99.3% of the atoms would be of uranium-238 in the natural uranium, and only a very small percentage, which is 0.7% of the atoms, are of uranium-235. But among these two isotopes, the isotope which can actually undergo fission is uranium-235, which is the scarce isotope. Means this is called as fissile. And this uranium-238, the abundant isotope in the natural uranium, is non-fissile. So fissile means the isotope which can actually undergo fission is called as fissile. When you hit it with a neutron, it would split into two smaller atoms along with the release of energy and more number of neutrons, and a self-sustained chain reaction gets started. So it would happen with uranium-235. That, okay, fission, this uranium-238, the abundant isotope, would not undergo fission. That means it cannot be used as a fuel. Fine. So it is non-fissile. So what happens? So natural uranium would look somewhat like this. Suppose these bigger circles are uranium-238, which is non-fissile, and let's say these small dots, they are uranium-235, which is actually fissile. So natural uranium, or you can add more of this uranium-238, means in the natural uranium fuel, majority of the atoms would be of uranium-238, which is non-fissile, and the actual fissile material, which is uranium-235, is very small in concentration, only 0.7% here. So in its natural form, the natural uranium is not a very efficient fuel. So in its natural concentration, the natural uranium would not be a very efficient fuel. Why? Because the actual fissile material there, which is uranium-235, is very small in concentration. So for different purposes, we need to increase the percentage of uranium-235, and this increasing the percentage of uranium-235 is called as enrichment of uranium. So enrichment means enrichment of uranium, it simply means increasing the concentration of uranium 235, which is the fissile isotope, concentration of uranium 235 in the natural uranium fuel. This is called as enrichment of uranium. Increasing the concentration or percentage of uranium 235 from 0.7% to anything above it is called as enrichment of uranium. Okay, and enrichment, why do you do this enrichment? It makes the fuel more efficient. Okay, so now for peaceful purposes, okay, such as for example in the nuclear reactors, for generating power. Okay, for the peaceful purpose, how much enrichment is required? Generally 3% to 5% is usually more than enough for your peaceful purposes, that is for generating electricity through your nuclear reactors. The degree of enrichment required is not more than 3% to 5%, it is more than enough. And this uranium, okay, this uranium is called as low enriched uranium, LEU. Okay, so for the peaceful purpose, very high degree of enrichment is not required. 3% to 5%, usually more than enough. Okay, so this is and this uranium is called as low enriched uranium. But for making nuclear weapons, enrichment required is more than 90%. So this is more than 90% means concentration of uranium 235 should be more than 90%, okay, for making the nuclear weapons. And this uranium is called as highly enriched uranium, HEU, or you can also call it as weapons grade uranium. So this is the issue, that Iran possesses this kind of uranium, highly enriched uranium. Okay, so it was found out that last year that Iran had enriched their uranium more than 60%, and they can continue to enrich it more and more, and once they reach 90% or more, they would be in a capacity to develop a nuclear weapon. And this is what the US and its allies are afraid of. They don't want Iran to possess a nuclear weapon. That is why they are pressurizing Iran to give away its enriched uranium, because there are chances that if they continue to do that, okay, very soon, okay, they would be able to make a nuclear weapon out of it. That is called as, so that is the issue here. That is why US is pressurizing Iran, fine, for this purpose, highly enriched uranium that they are possessing. And where is this enrichment done? So the enrichment is done in facility known as centrifuge. Okay, this enrichment is done in the facility known as centrifuge. So centrifuge is a system, okay, in which it rotates at a very high speed of more than 50,000 to 70,000 rotations per minute. So enrichment is done in centrifuge, and this centrifuge, it rotates at a very high speed of more than 50,000 to 70,000 RPMs, rotations per minute. And here the uranium is used in gas form. Okay, you gasify the uranium. Okay, and we know that it works on the principle that the uranium 238 is 1% heavier than uranium 235, and based on the difference in their weights, uranium 238 is heavier, 1% heavier than uranium 235, and when it rotates at a very high speed, and the natural uranium is used in the gaseous form there, it rotates at a very high speed, and based on that, uranium 238 being heavier, it would go towards the edges, and they keep removing uranium 238, and uranium 235 would be in the center. So the concentration of, because you keep removing uranium 238, whatever is left behind would have, now the fuel would have higher concentration of uranium 235, which is the fissile material. So this is how, so it is the centrifuge where the enrichment is done. Okay, it is this facility, okay, for the enrichment of uranium. So now, simply speaking, that natural uranium is a mix of uranium 238 and uranium 235 atoms, in which abundant isotope is uranium 238, which is non-fissile, and the scarce isotope is uranium 235, which is actually fissile. So in its natural form, the uranium, natural uranium fuel would not be very efficient fuel. Hence, it's there in the natural uranium fuel, you have to increase the concentration of uranium 235, okay, to make the fuel more efficient, and it is done in the facility known as centrifuge. Okay, it's a system which rotates very fast, and based on the difference in the weights, uranium 238 and 235, okay, are separated out. Uranium 238 would move toward the edges as it moves very fast. They keep removing uranium 238, and inside you have higher concentration of uranium 235 with you. And if you are able to attain a very high degree of enrichment, then even the nuclear bombs can be made out of it. This is what the US is afraid of. So that is why they are now pressurizing Iran to go for downblending. Downblending. So, and before that, and the enrichment would now look somewhat like this. Earlier it was like this. You had large number of atoms of uranium 238 and a very small percentage was uranium 235. Now this one is enriched uranium. So if you keep removing uranium 238, so the percentage wise the uranium 235 would keep on increasing. This is called as enriched uranium. Now downblending. So now the US is now pressurizing Iran that it should go for downblending of its enriched uranium. So downblending is what? It is simply the reverse of enrichment is called as downblending. And what do they do here? They would mix the enriched uranium with, let's say, natural uranium. They would mix the natural enriched uranium, which has a percentage of, let's say, highly enriched uranium you had. So in that, if you keep adding this natural uranium, so overall percentage of uranium 235 would keep on reducing. So they want to bring it down to concentration to be less than 5%. Okay, so they want to, okay, this is called a downblending, means with the enriched uranium they are mixing the natural uranium. Natural uranium means where uranium 235 would be only 0.7% and uranium 238 99.3%. So it would change the concentrations now. So naturally with you are mixing it with this, so and the final target is that they want to bring down the concentration of uranium 235 to less than 5%. So the downblended uranium, hence you cannot make nuclear weapons out of it, it can only be used for generation of power in the nuclear reactors. Fine? Okay. Thank you everyone.